All right, guys, I think I'm going to be bold. We'll see how long this takes. I'm going to do 10.2 and 10.3 together. I'm going to put your homework together. 10.1 was harder, I believe, than these two. So if you struggle with 10.1, 10.2, and 10.3, should hopefully be easier. So we're gonna be finding surface area again, only this time of cylinders. Okay. So let me change this to black. Okay, so of cylinders. All right, so what is a cylinder? A cylinder is a solid that has two parallel, identical circular bases. Okay, so my base, as you can see, are the circles on top and bottom. Okay, so this and this. Okay, so as you see, we also have a lateral, there's that word again, lateral surface, okay? So it is what wraps around it. So I actually put this can in here so that we could look. The lateral surface is the wrapper that goes around the can, not including the top, right? So if you were trying to figure out the surface area, this is a real world example, of what to wrap around the outside of the can, like a label, you would use lateral surface area versus total surface area. Okay, so just like the last time, it's basically bases plus your face, right? So the lateral surface is your lateral face essentially. So we're just going to find the two bases, and then we'll figure out the lateral surface, which seems tricky, except in this case it has its own formula. Okay, so here's another formula. Geometry's full of them. If I were you, I'd keep these formulas handy. Make your own formula sheet. Use mine that I posted on Google Classroom. But the bases plus the faces again, or plus the face, okay, in this particular case. Wow, I'm just rhyming like crazy today. Okay. All right, so here's the net. Remember, we call this the net. Here's the net of what it looks like. So you've got two circles, 1, 2, and then you've got the like our can, you've got the wrapper. I can't think of what you would call those things. Label. You've got the label that goes around the can. Okay, so think of that as the lateral surface area. So our two... So what is the area of a circle? Well, the area of a circle is pi r squared, correct? Okay, so why is there a 2? Pause the video and see if you can figure it out. The reason there's a 2 is because there are 1, 2 circles. So that's why for the surface area of a cylinder, we are going to use 2 pi r squared because it's just 2, there's 2 of them, right? Okay, so we can find basically the pi r squared of this circle and then multiply by 2 to get the other circle. Got it? And then the lateral surface area, okay, is derived from the radius of the circle, and it is 2 pi r times the height, which makes sense because it's the circle, it's how far it has to go around, plus... So here's this thing. So it's how far it has to go around the thing, right? Plus how long, right? If it's that long, then I'm going to have a certain number. And if it's that long, then it's going to be twice that certain number, right? Approximately. So that's why the height is important in the lateral surface area. Okay, so, all right, so let's jump in and do some. Finding the surface area. Oh, I meant to delete all of that. Oh, I meant to delete all of or erase all of their work. Okay, but let's just, we can work with this. That's fine. We've got the whole page. Okay, so we're just going to look at this. So basically what we're doing, try to ignore their writing. Let's just watch my penning. Okay, so we've got our circle here. And now, so for the bases, okay, we're going to use 2 times pi r squared. All right, so we've got the 2 pi, and then we need to know the r. Well, they've given us the r. Remember, the radius is halfway. It's from the center to any point on the outside of the circle. So it's half of the diameter, right? Diameter's all the way across. Radius is half of that. So the radius in this case is 4. and that will be squared. Okay, so what we've done here is we take Jim Doss here. 4 squared is 16. 16 times 2 is 32. So that's where they're at up here, 30. So our bases are 32 times pi. Okay, and they're going to use pi like it's kind of interesting how they do this. So I'm actually, it was almost meant to be here because it gives me an opportunity to, so the lateral face here, the lateral surface, so surface area is, in this, the bases plus the face, the single face. All right, so anyway, they're going to use pi like a variable, and we'll be able to add them together as, like, so if you were combining 3x plus 2x, you would get 5x. So in this case, if you have, they're going to have 32 pi plus 24 pi and get 56 pi, which is a cool way to do it, and then you plug in pi versus doing it ahead. You can do it ahead, but it looks like you might get a slightly different answer than big ideas if you don't combine it. If you combine it, so in other words, let me just be clear here. At this point, I could have multiplied 32. At this point right here, I could have multiplied 32 times 3.14 and 24, which we haven't gotten yet, times 3.14. Okay, so moving forward. So our face is 2, and we have to remember, this is a formula. I'm not making this up. You don't have to figure this out. This is a formula, okay? 2 pi r h. So 2 and pi are given. Radius we get from the drawing, which is 4, and the height is this part right here, the height of the cylinder, right? And it's 3. So we come down here and we go 3. My 3 erased. Okay, and now we just multiply. So 4 times 3 is 12. 12 times 2 is 24. So that's where they got the 24 pi. So 32 and 24 equals 56 pi. And we'll just trust their math that 56 times pi is approximately equal to, they rounded obviously, 176. And that is millimeters, and this is area again, squared. Okay, all right, moving forward. Now, in this particular one, they want us to find, be careful of these, the lateral surface area. So remember, that's not including the bases. So no, we do not want those, okay? So basically what that means is we are going to, so normally we would have the bases plus the face, right? That's the surface area of the whole thing in this case, and that would be, let's just get used to this. So this would be 2 pi r squared plus 2 pi r h. Okay, so notice we take out, on the face, we take out the squared part and we add an h instead. So if you want to try to memorize it. Okay, so in this case, we do not need this because it's the lateral. All right, so it's that simple. Okay, so we're going to go 2 pi, that's given. The radius has to come from up here, but they've given us the diameter. Hopefully you notice that immediately. So the radius is just this part, which is half of the diameter, which would be 4 instead of 8. The height is this thing, and that is 5. So 4 times 5 is 20. 20 times 2 is 40. So we get 40 pi. So 40 times 3.14. I actually don't have my calculator, so I'll be right back. Sorry about that. I'm not going to start over for that. All right, so we have 40 times 3.14, and we get 125.6 feet squared. All right, and that's it, guys. So lateral and regular surface area, it's actually like, hopefully you're like, oh, this is easier, because I believe it definitely is compared to the last one. Okay, so now we're going to talk about 10.3. All right, so surface area of pyramids now. Okay, so we've done prisms, which was the hard part because you had to kind of figure out all the different prisms. and which side was which. These also are a little bit easier, in my opinion. Okay, so pyramids are there's different types. Okay, so we have one with a triangular base, so that's called a triangular pyramid. This is a square base, so that's a square pyramid, and hexagonal base, hexagonal pyramid. Okay, so let's look at some of the the formulas here, or not the formulas, but more about this. So the regular pyramid is a pyramid whose base is a regular polygon. Now remember, in a regular polygon, all the sides are identical and all the angles are identical. All that means is if it says it is a regular polygon or a regular pyramid, then it will be then basically all that's saying is that all of its faces are the same. So if you solve for 1, then you will just multiply by 4 in this particular instance. So bases, only this time it's one base. Okay, so that's something a little bit different about pyramids. So we have a base plus the faces. So base plus faces. Okay. All right. So, and really, guys, you don't have to memorize these faces and bases and which one's singular and plural. Like it, you should be able to look at this guy and say, okay, this has one base. Do you see another base? Do you see another rectangle or at the bottom there, or square? I'm not sure which one this is. No. So it has one base, and then it has 4 faces. Okay, and this is the what you call it, whatever they call those, where they unfold it. Okay, I'm drawing a blank. All right, so let's do example 1. Find the surface area of the regular polygon. Okay, so the surface area is equal to the area of the face plus the area of the base, which is this square. Yep, that's a square because it's 5 by 5. The area of the square base plus the 4 faces, right, in this case. Okay, so what we have is so let's figure this out. So the area of a square is simply this side squared, right? So side squared would be 5 squared, which would be 25. And then the 4 faces, so we're going to multiply 4 times, and then we need to figure out the area of a triangle. Hopefully we figure here. I'm gonna do the dot here. So wow, I'm gonna do the dot. So so we're gonna have 4 times, and then pi, or I'm sorry, that's the circles now. 1/2 base times height, right? 1/2 base times height. So now we just need to plug this in. So 25 plus 4. 4 is the number of sides. 1/2. The base of this triangle is 5, right? So that's the same as that. So times 5. And the height is always connected to this altitude that drops down and has the right angle, okay? So always be watching for that right angle to see which one's the height. Not that it matters, because of the commutative property, we can multiply times whatever we want. Okay, so we have 25 still over here. Plus, well, we can multiplication. We can multiply these in any order we want. 1/2 of 4 is 2. 2 times 5 is 10. 2 times 5 is 10. 10 times 8 is 80. So we end up with 105 inches squared. Okay, and moving on. Find the surface area of the, again, it's just the only thing regular pyramid means is that this, and this, or in this case, this side, and the side you can't see in the back are all the same. Okay, so we have, in this case, we have 3. So we have surface area is equal to the base. And in this case, it's a triangular base plus 3, the 3 faces. Okay, so here we go with some formulas. So the triangular base is 1/2 base times height plus the triangular faces, so 3 times 1/2 base times height, because there's 3 of these triangles here that we have to figure out what that area is, and then we're done. So surface area is equal to 1/2. All right, so we're doing the red base now. All right, so the base of this, let's clean this up a little. Okay, so the base of the triangle, we know the height is this one because it's got this part with the right angle. So this is my height, this is my base. So 10 is my base. 8.7 is my height, okay? And then I'm gonna add to that 3, let's just do all of it real quick. 3 times 1/2 times the base of this triangle is the same as the base of the red triangle. So the blue triangle here I'm doing now. This base though is the same, right? They're all 10. 10, 10, 10. So that'll be 10, and that will be, the height is this one right here with the right angle attached to it. So it's going to be 14 times 14. Okay, and then we're just going to have to get out our calculators and do some work. I know 1/2 of 10 is 5, so I don't even have to put that in my calculator. So 5 times 8.7 is equal to, so the surface area is equal to, notice how I keep my equal signs straight. I'd like to keep my pluses somewhat straight. You can, on paper, when you have more room, you can really even line up your pluses better so that you can keep your faces and your bases on kind of in line with each other. Anyway, I digress. Okay, let's see. So we have 40, this side is 43.5, and that's plus, well, I'm going to do 1/2 of 10 is 5. 5 times 3 is 15, so now I'm going to do 15 times 14 is 210. And don't worry, you guys could totally just plug this whole thing right here or this whole thing right here in your calculator and see what you get, but I'm just kind of showing you commutative property more and more. You can, because it's multiplication, I can multiply in any order I want, right? Okay, so 210 plus 43.5 is equal to, well, that'd be, I don't need the calculator for that, 253.5 meters squared. All right. Okay, now this one right here, this is the last one. Okay, so the roof is shaped, so what we're going to do is we're going to try, let's read it. The roof is shaped like a square pyramid, correct? Okay, so that means square. This is my worst one for the record of drawing, so I've always struggled with this. Okay, but this thing, that's that. This is my worst one at drawing though, is these square pyramids. Let's just get rid of that. Okay, whoops. Okay, so we've got this square pyramid. One bundle of shingles covers 25 square feet. Okay, hopefully you're thinking what I'm thinking. I'm going to use this 25 square feet eventually to divide, right? Because one bundle is this much. They've given us a unit rate, and that means I'm going to basically divide the total square feet by this 25 to figure out how many bundles. Okay, hopefully you guys are starting to recognize that in your story problems. Whenever they give you that, they're going to want you to divide because they want to know how many bundles. How many bundles should you buy to cover it, right? So we figure out the total square feet, divide it by this 25, and that will tell us how many bundles to buy. Notice, think about this. Notice that we are just talking about this outside part and the part we can't see, but the square base is not going to be shingled. So this is a case where we do not need the base. So surface area equals the base, the square base, plus the faces. In this case, we have 1, 2, 3 is going to be there, and 4 is going to be here. So there's going to be 4 faces. But in this case, we do not need the base, right? So we're just going to exclude that. So all we need is the 4 faces, okay? So the 4 faces, let's just get rid of the base completely. So we're going to have the 4 times the faces, and the faces are all triangular. So 4 times 1/2 base times height, and now we just need to figure this out, okay? By the way, this is called the slant height. I'm not sure we talked about that. So it's no different other than... let's see what they say about that exactly. Yeah, slant height. The height of each triangle that is part of the faces, those lateral faces, is called the slant height, right? It's not the... So basically it's this triangle's height, but since it's slanted, they call it the slant height, okay? I don't think I said that. So anyway, okay. Very simply, let's finish this up. Okay, so surface area is equal to 4 times 1/2 times the base of this. So we're going to look at just this triangle right here. I'm going to outline it. Okay, the base is 18. The height is this one connected to the right angle, which is 15. And then I'm going to, I'll take half of 18, which is 9. 4 times 9 is 36, so 36 times 15 should give me the correct, and that is feet squared. Okay, so remember, 540 square feet is how much roof we need to shingle, okay? However, we need to figure out how many bundles, right? That's the question, is how many bundles? So 540 divided by the 25 equals 21.6, but you can't buy 0.6 from the store, so we're going to buy 22 bundles. All right, very good. That's 2 sections knocked out. Good luck on your homework. If you have questions, let me know. Talk to you later. Bye.